Well, I've decided we've got to tackle this side panel. So obviously to have windows from the factory, we're now going to put a sheet through here. So I've had a piece of sheet metal, 0.96 cold rolled metal that I keep talking about. And this is tapered, but I've decided to have it cut just a little bit wider so I can sit it in from behind, and we'll sit it on one edge and then scribe the rest of it in. But before we can do that, we've got to remove this center section. It's got a few spot welds in it, so I've just clamped it up. We're going to drill those out and then cut this out and leave that support bracket in place, because I want to make sure this doesn't collapse on me. So I need to make sure I maintain that edge. And then we've got Darren for a couple of days, so we're going to work together, get that panel in behind, scribe it up, cut it out, and then tack it all in with a TIG. And then we've got to weld that whole circle around there and hopefully not get too much distortion. So we'll just do a bit of filming as we go. Fortunately, Louise grabbed me to come out now and do a bit before we get started, because normally once we jump into it, it all happens in a hurry. Righto, so I sanded off that paint just to pick up where the spot welds were, and we've used the spot weld drill, which you've seen us use before. So that keeps the back part intact, but gets rid of the top. And we've just put a couple of clecos in there. Now, for people that haven't seen a cleco, it's a reusable rivet. So it's super handy. It's a 1/8 drill bit, and it's just got a button on it. Yeah, just pull one of them out, Darren, and we'll show them. So you can take that out. You've just got your 8th hole there. We'll weld up later, but it enables us to keep this bracket in place and let us trim this face off. So they just go back in the hole. Spring loaded inside, clamps up, holds that nice and tight, and they're readily available. If you just search Cleco, you'll find them online and you'll be good to go. Okay, so we've managed to get that sheet now cut, and we've made it a little bit oversized, and I'll explain why in a minute, and clamped and Clecoed it in place. So I've used a couple of different tools. This one here that I've scored from somewhere to get the angle of the window, because what I wanted to do was make this panel like 10mm longer, and I've been able to sit it up behind this lip from the inside, and we've put Clecos along the bottom to make sure it stays in position, and then clamps at the top where they were long enough. And the reason we're doing all that is to now be able to scribe that shape so we can cut it out back to that scribe line, because I want it as close as I can. Because we're using TIG, we can do that and weld it with no gap. So I'm looking to have that gap like that. So you can see there the Cleco just coming through here. So we'll now pull that back out again and cut that excess off, and then we'll be able to use those Clecos on the bottom to put it back in the same position, and then tidy up any little edges, because it needs to be a perfect fit before we start welding, because once you start welding, things shrink and grow. So when that happens, you need to know where your problem is. So if you start off with a mil gap here and no gap somewhere else, and try and grind it up as you go, you just end up in a whole lot of pain. And I learnt that when I was doing tailspin. Righto, so we've jumped a bit ahead. So we've scribed that panel. We've gone through now, or Darren went through and cut that with a 1mm blade back to that scribe line. And this is where, if you're going to use TIG especially, it's crucial that you spend the extra time. What we're looking for is virtually no gap, or less than 1mm. So you can see here, this is touching, and up the top, when it sits in, it's pretty much a clear fit. Now we've got a little bit of movement around the place, but if I push that in and out, you can see it's virtually an exact fit. And I'll jump past the camera here. When I come here, you can see there now that that's a nice clean fit. And I said earlier we'd put the Clecos back in. Well, of course there's no metal for that Cleco, but fortunately in the middle we've got that brace behind. So we've got one here and clamps. Now, especially if you're using TIG, but any welding really, but if you're using TIG welding, everything's got to be clean. So what we've been doing is we've gone over all the edges with either 120 or Scotch-Brite on the little machine, and make all these edges bare metal if they weren't already, and even the face of this panel here that's quite old, obviously, that we sand all of those edges before we get to this point, so that when we're welding with TIG we don't get contamination in the weld, because as you're welding, if there's a little bit of paint or a little bit of rust, it'll actually want to pop the weld and it gets very frustrating. So on the inside, come around the back there, the same applies on the inside. So I've gone around here with this little machine with some 120 on it and cleaned all that up so that I've got bare metal, nice clean metal all the way along, and that now will start the welding process. So the issue is always going to be, how do we stop this happening? So it's quite easy for that to have a big warp in it. Fortunately, with this returned edge here, it's going to give me a bit of strength, but we're going to start in the middle and we're going to put tacks probably every 6 to 8 inches, working our way out from the middle, down the sides, then we'll come back between. But you've got to make sure that you air cool every tack, because as this panel warms up, it's going to want to grow, and then it's going to end up having no room here. So we should be able to tack all of this in and keep our edges all nice without having to sand the edges off it. If you're finding you're doing a rust repair, for instance, a small panel like this, and it grows, then you're not cooling it enough. You're letting it grow too much. And then if you trim it off, weld it, it's going to shrink back and it's going to want to pull all the metal from around. So weld, compressed air, weld, compressed air. A lot of patience, and it's quite time consuming, but it'll save you a lot in the hammering. When I get this in, I have no doubt I'm going to get a few buckles, and if I do, at least I can get either side and I'll hammer it up. And if I'm unfortunate enough to have that problem, you'll be able to see how I solve it. So we're going to double team on this. I've just got Darren holding the hammer so that it keeps it nice and flush, and with the timber it obviously doesn't have any heat. He's got the air gun in his hand. It's handy if you've got a mate or someone around to give you a hand to do that. I'm just using by memory 1mm or 0.9 MIG wire, so it's a low tensile MIG wire, because I'm not going to need a lot of build up. And I'm just going to start the tacks and hopefully everything goes to plan. Let's see. Good earth. Now, because TIG's fusion welding, so you're basically melting both pieces of metal, and the filler wire, you probably don't even need filler to do this, but just not like a bit of extra strength. You only need just enough heat to melt it, but I'm using a pedal. You'll see down on the floor down here. Some TIGs come with an adjuster on the handle. With this, I can control, you can hear it turn on and turn the gas on, but I get to control how much heat I've got, so I can regulate that with my foot. Because when I first got this TIG, it didn't have that, and I struggled to weld sheet metal with it. With the pedal, it makes it so much easier. There's still a learning process, but you can turn your heat down on the pedal, and then when you apply your foot, that determines how much heat you get when you're actually doing that weld. Righto, let's move along. I don't know how far we want to go there. I think a bit more, go about 6 inches, pull a bit more, yep. The other thing while I think of it, if you go too quick with the air, it'll actually blow the molten metal away. So you've got to let it sort of lose a bit of that cherry red before you can cool it. Yeah, I know, I just put all together to start with. Come back a bit when you... So far so good. Just hold a little bit there once. Not quite flush. There it is. So you need to be 100% sure that you're flush. We're just having a little bit of trouble getting that to sit up on the top edge, because if it's sitting behind and you tack it, then it's always going to be behind. You can panel beat it, you can do what you like. So it's just going to want a little bit of pressure in there, or I might even run the blade along there. So it's fitting good there, but not here. So I'm just going to run a little sander on there, take a little bit of metal off. What we'll do is we'll put a tack up on this corner before it gets any tighter. Alright, we'll put one there, and then if need be I'll run the 1mm along there and take a bit out of it. I need a bit of room to work, so. No. So it's a little bit tight here. It's probably only half the width of the metal out, but I don't want to weld it like that. So I'm going to go around the inside and just push on a little bit, see if it'll go. If not, I'll probably end up running a 1mm blade along and taking a bit of metal out so I can move it. What you don't want to do is pull that out with a screwdriver or something to get in there to grind the back edge, because then you're going to stretch this metal, and you can't afford to play with the shape of this, or you're going to end up making a whole lot of work. So I'll probably leave that for now, and we'll go along, get some of this tacked in, and then come back as we do something different. Righto, so we've got all those tacked in and it's come up pretty good. And what I'm looking at now, if we put a straight edge over this, where I've put that is really good. So that the face here to the centre is nice and straight. But I'm sure if I put it somewhere, you can see it's a bit full in the middle. But right at this point, you can see the bit of light coming through there. where this is going like that. So what I'm going to do now is I'm going to put a flat dolly on the outside, give it a little tap from the inside, probably even with the timber part of the end of the hammer, because I want to make sure I've got all these areas up nice and square. And you need to do that before you get too carried away. So at the moment it's bent this way a bit, it's a little bit full there, but when I move this, I can see this moving. So I just need to make sure I've got everything where I want it to be before I start welding it, so that if you weld it in the wrong position, it's harder to get it back. The other thing is, not everything goes to plan. You can see here, I burnt a hole there when I was tacking, and what happened when I moved the pedal without knowing, I moved the controller on the side and up the amperage, and that's what happens when you've got too much amperage. So sometimes it doesn't all go to plan. So the next stage now, I'll get that straightened up. Darren's going to start making the other side, and there's a little tip that we didn't think about. Once you've got one made, trace out on the other one. So now we've got to go back and measure the other one to make one the same. So it's always a learning process, and sometimes you just got to make sure you're thinking ahead all the time. Righto, so this is progressing pretty well, and I just got to keep remembering to turn the camera on and get a bit done while we're making things happen. So we started off with our spots this far apart, and we've gone around and gone in between those each time. So we end up with less and less gaps, and now we're down to doing between those, and we're pretty much all the way around to here. And I've just stopped with these to be able to show you on the camera the process that we're going through. And the biggest thing, see how that's nice and tight there where there's no gap. So the reason for that is we're TIG welding, so we want to be able to just weld along that. The reason we're doing short runs like this is to keep it cool, and we do that run, blow it with air, then the next one and the next one. When you make this panel fit, if you end up like we did here, where you end up with it's probably only 1 mil, maybe 1.5 mil gap, it's a whole lot harder to weld, and you can see here just the amount of weld that's on there compared to these little soft ones. So we'll go along now and get that all welded up, and then I just had a little experiment here on the other corner that was like this, where I've used the small Mercus grinder. And I'm going to put my earmuffs on and just show you how that works in a minute. So the whole process here is limit the amount of heat, try and avoid the warpage. Now at the moment this end's nice and tight, and then we've got a little bit of movement here. I think once we weld this a bit more, this will tighten up. But we've got a little bit of oil canning here. So we've clamped these back on at the top to try and get a little bit of strength back into it. But once I get it fully welded and ground, because the other problem is when you're grinding it, is you actually end up with as much heat from the grinding as you do from the welding. So just be careful, you still need to have your air running. Once we do that, and I'll grind it up inside and out, I'll then, if need be, I'll do some heat shrinks. But so far so good, it's pretty flat. And we'll just keep ticking away at it. So I'll just grab my earmuffs and my gloves, and I'll just show you how this little machine works. Righto, so I'm using the Mercus grinder, little battery grinder. I'm using 60 grit. They just screw on there like that. And I like these because they're nice and flat. And I'm just going to take 80 or 90% of that weld off, and then I'm going to change to a flapper disc. So I've sanded that on the inside as well now, and I've done that because if I put my ruler on here, where the weld is, it's a little bit low. So what I don't want to do is grind a big curve in there. So I'm just going to put a dolly on the face and knock that up a bit. I'm just going to change over to an 80 grit now in a flapper, because I don't want too deep a grooves. Now where we've got a little bit here, I would say if I put my ruler back on, it's probably still a bit low there, so I'll tap that up in a minute and then we sand it off and we end up getting that sort of look. So I just thought I'd show you that while I've got some heavy weld there. What we're going to do now is get it all welded up, and then we've got that long process of sanding and grinding to get it all back up. And then depending on where we're at with it, we may need to do some heat shrinking as well. And if I do that, then obviously I'll show you what I'm up to with that. Right, so I've got that all welded, all sanded up, and I'll go through in a minute just the products I've used on that, because I changed as I was going along. I was learning, and I keep saying all the time I haven't done this before, and more often than not, that's the case. So I've welded through the middle of panels, but I haven't necessarily put a panel like this in. So where I'm up to now is I've got it all cleaned up, and as I normally do when I put a ruler on here, you can actually see just how much that can change shape. So it's quite tight in the middle. You know, it's sitting nicely there, but it's still quite loose. And then here, you know, it's good through that corner. So what I've been doing is I've taken a flat dolly, like this one, and I've put that on the outside and hammered from the other side coming back on this lower edge, because you know this was about 10 mil wide. It's pulled it in a bit, and when you weld anything at all, as it cools it's going to pull. Now we've tried our best to limit how much that will happen, but it has done it. And what I'm doing now, and I can see here very clearly that I might have hit that a bit too hard on the inside, so now it's high there than it is there. So what I've just started to do is to put this dolly on the inside and go along on the outside with my slapper bar, so I can get all this outer edge nice and square and lined up. And I'm probably going to avoid doing any heat shrinking until I get the roof on, because what I'm finding is that if I've got that and I hold a little bit of weight up here, it tightens it up a lot. Now the roof gutters fit on here and it comes out, you know, 10 mil, and then the roof sits on out here, and that's going to hold all that together. So I'm thinking that I don't want to make this all nicely finished, put the roof on, and then it pulls it a bit and changes the shape. So my aim now is to get it to sit nice and flat like that, which I've been playing with this end. And through here, at the moment it's a bit high there, so I'm looking to get that down and get this here out a bit and not be too worried if it's got a bit of a curve in it until I get the roof on. So to get myself to this point, what I've been doing is, you would have seen in some of the earlier videos in this video, I was using this little machine. So I like this because it's very manageable, and I ended up going to the 36 grit. I was using the 60, I've gone to the 36 and on the very high speed, and that's taking the top off the weld really nicely. and then changing over to the 60 grit. So I was using the 80, I think the 60 is better. And once you get on the high speed, that enables me to flatten it down and clean it up. And then I've been using the grinder, just my normal 4-inch grinder with a flex fit strip and clean disc, to get rid of all of the different colours from the welding where the metal changes colour, to make it easier for me to beat it. So that's what you're seeing with it cleaned up. Now I mentioned about the wire, so I've got that out. I had to cut some more up to make some more. So it's actually 1.2 mil, and down here, this ER70 S6, the 70 is the tensile. So I keep talking about having low tensile, so 70 is the tensile I'm using, and then the same in these. If I've got a bit bigger gap, I'm using the hard 1.6, I'm sure. Yep, 1.6, and that's the same, ER70S. So that's the welding rod, and then I'm using argon gas on the TIG. Now, a few people have asked me what TIG I use. So I've had this for some years now. So it's a Uni-TIG AC/DC 200. And we pretty much just do sheet metal. So I don't tend to change the controls on the front very much. But I do use the pedal and control my temperature, you know, how many amps I'm running. So Louise might get a close up of the front of that. I'm sure someone will tell me there's a better way for me to use it, but it functions well for us the way we've got it set up. So that's pretty much where I'm up to. What I'm going to do now is I'm started cleaning up this top area a bit more as well. I'm going to get some epoxy on that. I'll probably just brush it on just to seal up that area, because Jamie shouldn't be too far away with our drip gutters, and then we can get those on. And then in between jobs, I've been messing around with the roof, because I need to get that into epoxy as well, so it can go on as soon as we get all that back. If you're doing this sort of work, having the right tools makes all the difference. So what I'm using here now is a Merker. That's it up there in the box, so it's I can't even pronounce that, but the old aggro I call it. Really good bit of kit. I mean, it's got variable speed, and it is a grinder. It goes very fast if you crank it up. And it comes with Scotch-Brite, all your different grits, and your sandpaper, and then it has flapper discs as well. So when you're in these small areas and you've got little ridges and things that you're trying to work with, it's very visible. You can see what you're doing. The fact that it's battery, it won't grab, because when it grabs, it actually just locks out the battery. So really good tool. I'm loving using it, and it'd be worth having a look. I decided that I'd put some primer on here, so I'm going to put some epoxy urethane onto the panel where I'm finished. So I've got all of the edges cleaned up, ready to go, and I've masked that middle section off because I've finished welding, but I'm sure I'm going to have to do some heat shrink, and I don't want any paint on there when I do that. But I'm just getting sick of chasing my tail with these areas up here especially. We'll get them cleaned up now, get some primer on it, and that way I don't have to be worrying about chasing rust, surface rust as I go down the track, because I'm not getting as many hours as I'd like onto it, but I need to seal it up. It'll just make less work for me. So I decided this morning, Saturday morning, I'd clean it up, made a bit of noise, and now I'm just going to squirt a bit on there in the main shed and seal it up. Righto, so that's a couple of coats on there. Really just a provisional coat to stop that surface rust. We should have the gutters within the next couple of weeks hopefully, and we'll work out where we're going to weld that. Not sure yet if we'll spot weld them on or whether we'll plug weld them. Had a bit of a rush of blood and decided I'd get this door jamb sealed up as well. So I've welded up these lines through here, down here, I've done that just with MIG. Same through here, just to get a nice clean look. You know, the old story, not meant to be a show car, but I know the look that I'm after. So that's, I'll get that in some epoxy because I had a little bit left over when I did the side. So I thought, well, I'll spend a couple of hours, jump in with the MIG, make a mess. Got every grinder known to man out at the moment. I'll clean all that up. Righto, so I thought I'd better show you just what I did with these joins. So you can see the factory join here, and again down here, and up this one. I'm just welding those up because I want a cleaner look. And it's a visual thing more than anything, but also just to make life a bit easier when you're cleaning it, and it just looks a lot nicer. You open the door up and you look in and you don't see these lines. So the first thing I'm going to do, this has been paint stripped, and what I'm going to do now is run over it with a Scotch-Brite, various couple of wire wheels, and I need to make sure I get all of the factory sealer, this sort of sealer in here. Need to get all of that out before I try and weld anything, otherwise it's just going to splatter and play up. So I'll jump in and make a start. So a couple of little mods I'm making. So this area here, sitting quite up, a lot higher this point than this point, probably 3 or 4 mil. So I've just run the 1 mil blade along there. I'm going to tap that down and weld it back up. So when the aluminium kick plate goes on here, it'll actually sit down nice and flush. The rest of it's pretty good. I've tried to get rid of the bronze where I'm going to be welding. I've also cleaned up the faces on here. So I'm going to leave this edge down here with like a seam sealer, because I don't mind that look. I just don't like all of these joins everywhere. So I've knocked down a couple of lumps that were sitting up here, and I've got as much of that sealant out of there as I could. So my aluminium plate will run around here and back this way. So this one's quite flush, which is good. So I'm going to jump on the MIG now and get into that. So if you're going to weld stuff like this up, where you've got 2 factory overlap panels, I've just gone along with a little wood chisel, got in behind there to open that gap up a bit so I can get a scribe in there. And this come with one of my paint cleaning kits, I think. So I can just get in behind there and pull out that old sealant, because when you go to weld it, the sealant's going to get hot, expand and pop your weld. So I've just knocked that out a bit, you know, just like this, by putting that tapered edge in there. Now that I've got it clean, I'm going to knock that back in. So it's nice and tight. Now I'll just run the MIG down there and then grind it up, and I'll have a nice round edge, and it should weld fairly easy because it's nice and clean. So this MIG that I've been using, I've had this for a very long time. It was my dad's, and when MIG welding first came out, I'm sure that's when he bought it. And as you can see, it's only a 140. With what I'm doing now, I'm running it on 4 because I want a very hot weld so that I don't get too much build up and good penetration. But we go as low as 1 on this when we're actually welding panel steel, like 1 mil, and it struggles to weld any more than about 3 mil. So if I've got to do something heavier, I'll go next door and borrow Dave's. But it's been really good for what I use. I'm using a 0.9 wire, and what I'm going to do now is just do a couple of welds. Most of what I'm going to do now, I'm going to do spot welds, and I'm going to cool it with air as I go. This is very structural. The chances of this moving's, you know, virtually nil, but I'd prefer to cool it as I go rather than get everything really hot. So if you have a look there, it's like 5 little spots. What I'm trying to do is fill up that gap because I want this to come down flush with this bottom. So I'll sand down this way, sand in that way, and have a nice edge, and it won't look like there's a joint at all. So the tacking I find works better than doing a big long run. You could hear that then sort of playing up a little bit. I reckon that'd be a little bit of something in behind the two panels. Could even be a little bit of rust maybe, but more likely a bit of sealer. And while it's hot, it's trying to get back out from behind there. So coming down there, I'm just going to run that bead on the outside edge so it'll be nice and molten in behind, and then I'll be able to sand that down and I'll be able to run it nice and smooth. It'll look a lot more like this than having this ugly looking edge on it. Righto, so just to give you a bit of an idea, so I've been using a flapper with a 40 grit, running that flat up and down, trying not to take any of this parent metal away. I'm just looking to do the weld, and you can see here where the weld's still there. So I've run that along. Once I get close, I'll then go with this little one so I can get in nice and flat. So you can see here where it's ground with that one. And then I've just gone along and I've squared it up both ways. So that just gives me the shape, so I know nothing's going to get in the way of the door, but I've got a way to get rid of that line. And then the same down here, you can see the weld there. I've run a couple of runs in there because it's quite deep, and I've shaped that up, and now I'll go along and put some more weld in those little gaps. Now the reason I'm going to do that is I don't want to have filler or primers and stuff in those holes because it will shrink and eventually you'll see a bit of a line. But if it's all steel, it'll never shrink and it'll never change shape. So yeah, it's like weld, grind, repeat. Righto, so that's the desired look. This is epoxy thane in the Deltron range. You know, it'll be good for 6 months now. I've put two good coats on it so that it sort of fills up everything. I'm doing bits and pieces because I'm trying to seal it up because I'm not working on it enough, and the same here. So that'll be it for this week. I'll keep trying to get back to it, but I've got so much going on at the moment. We've got BOSSXC coming back in a couple of weeks for some work for MotorX, but we'll keep tinkering away with the van, and as we do, I'll bring it to you. If you like what we're doing, don't forget, subscribe to the channel, click the like button. If you want to know when there's something new, you've got to click the notification button as well. And if you've got any questions, don't be frightened to ask because I'll always get back to you.